Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 179 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the Observer's Notebook and also the coordinator of the training program within the ALPO. Thanks for downloading and listening. The Association of Lunar and Planetary Observers collects and analyzes observations of various solar system bodies and associated phenomena, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers, also known as the Strolling Astronomer. This podcast depends upon donations. You, our listeners, to keep it alive. If you enjoy what you hear on the podcast, you can donate to it via Patreon. You can start by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out. Just go to www.patreon, that's patreon.com/observersnotebook. And if you'd like to join the ALPO, you can for as little as $22 a year. For more information, visit us on the internet, www.alpo-astronomy.org. And we're also on Facebook. Just search for ALPO Astronomy. And this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear, please subscribe. That way you'll never miss another episode. Now, episode 179, and one of the most popular topics every single year, the Comets of 2024 with Carl Hergenrother. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. Today we're talking about comets, and that means we got Carl Hergenrother on here, and he's going to talk to us about the Comets of 2024. Welcome back, Carl.
Thanks, Tim. Glad to be here.
Yeah. Now, before we get into it, why don't you just give a little bit of update or background on the ALPO Comets Section?
Yeah, so the ALPO Comets Section actually goes back to around the late 50s, 1957 or so. And really came about because we had two great comets that were observable in 1957. Comet Aaron-Rowland, which was a comet that had been discovered a year previously and had gotten up to about first magnitude and showed a wonderful antitail. And then a few months later, we had a surprise comet, Comet Mercash. This is, of course, back in the days before all sky asteroid surveys and before SOHO and stereo were staring at the sun all the time. So you could have comets that kind of just pop up out of the sun, fully formed at 0th first magnitude with, 20-degree long tails. And that's what Comet Mercash was like. And so really it had been the first time, at least in the Northern Hemisphere, that we had seen great comets in many decades, and have two in 1 year. I mean, that kind of was unprecedented. You really have to go to almost the Hyakutake Hale-Bopp 96, 97 timeframe to get something similar, which was also kind of similar in that we had one comet discovered far out that was expected and kind of a surprise comet in the case of Hyakutake. Mm-hmm. But here at the Comets Section, what we do is we try to monitor as many comets as we can. Of course, the focus is usually on the brighter ones. And we have members or even people who aren't members who just want to contribute observations, just make observations of the comets. And they can be as simple as an image, a drawing, a photograph, just textual description. I saw this comet. It looked like blah. Or in some case of a lot of people, they will actually measure how bright the comet is. Mm-hmm. And then with those observations, we can actually map out the light curve and, figure out how rapidly the comet was brightening and fading, and learn a little bit about the comet's production and basically how it was acting during that apparition.
Okay. So before we get into the comets of next year, why don't you just give us a little review of what we saw this year?
Yeah, so at this time, we're in early October, so the year isn't quite over yet, but we have a pretty good idea of what comets will be observable even as the year closes out. It looks like for comets that got brighter than, say, 10th magnitude, that's kind of what I consider bright enough for, people with reasonably sized backyard telescopes. There were about 12 comets observable. We had 2 comets that reached naked eye brightness, so there's a little bit of a caveat there. The first was C2022 E3 ZTF. If you remember, a few months ago, it was all over the press as the quote-unquote green comet, or the Neanderthal comet coming back for the first, seen for the first time in 50,000 years. And of course, I kind of chuckle because all bright comets that get within about 2 AU of the sun, if you image them, are green. That's just the color of the gases in the coma. That doesn't mean to your eye they will look green. That doesn't even mean through a telescope they will necessarily look green. Sure didn't look green to me. Nope. But when you look at the images, color images, yes, it looks green. But they're kind of all green comets, to be honest, for the most part. At least at that, between about half AU from the sun to 2 AU, they're all kind of green. Inside half AU, they're a little more yellowish. And then, of course, it was the Neanderthal comet because, it hadn't been seen in 50,000 years. I'm pretty sure it wasn't seen 50,000 years ago either. The ZTF comet just happened to come as close to the Earth as it possibly could, which made this a great apparition for us. But that doesn't mean it came that close in 2020 or 50,000 years ago. So even if there were Neanderthals, tracking comets across the sky, they might not have seen it. But this comet did get up to 4th magnitude. And it was a circumpolar northern object, which means it was observable almost all night long. And 4th magnitude is kind of, it could be naked eye if you were at a dark site. Like if you're observing sight, if you can see 6 magnitude stars, you might have seen the ZTF comet at 4th magnitude, like I did, because my backyard gets down to 6th. And it just looks like a little fuzzy star for the most part. I did see some observations of people who could detect a tail with the naked eye, but you really did have to have pretty dark skies. Okay. The other bright comet was kind of a surprise, and it happened just in the last month. And this is Comet 2023 P1 Nishimura.
Right.
And it's kind of almost like a throwback comet, because here was a comet discovered by an amateur astronomer. Nishimura, this is his 3rd discovery. He had discovered one comet visually back in the 90s. And then discovered another comet a couple of years ago, just with a DSLR on a telephoto lens. Wow. And this is how he discovered this one. Nishimura is well known as a discoverer of galactic nova. In fact, I think he's discovered over 20 over the past 20 years or so. So he's always kind of looking at the sky, looking for new stars, nova eruptions, and does look for comets as well. So he happened to pick up this comet at 10th magnitude, which is really bright for a discovery nowadays. And you have to wonder why it wasn't seen by the professional surveys. As it turns out, they did image it back in January, but it was still pretty faint, and so it wasn't recognized as a moving object, let alone a comet. And then this comet, as it came close to the sun, rapidly brightened, and as we lost it kind of in the morning sky, it was about 4th magnitude. But it was still pretty close to the horizon. The sky was already getting bright. There was at least one naked eye observation of it at 4th magnitude. But it was a nice comet, even in my 10 by 50 binoculars, a little 4th magnitude coma with a half-degree tail, which was nice. Then, as the comet passed through perihelion, it kind of became more of an evening object. And even though it was way deep in the glow at twilight, it had brightened up to about 2nd magnitude. And while I don't think anyone observed it with their naked eye, because again, the twilight was so bright, there were visual observations and quite a few images of the comet at the time. And lucky for us, also, it happened to be in the field of view of one of our sun-watching spacecraft, the Stereo A spacecraft. And in fact, it's still in the field of view of that spacecraft. And it was kind of cool to watch the comet with its 2 tails, a dust tail, gas tail, each tail about 8 degrees long at its peak. So it was kind of nice to have, these surprise comets that pop up. Right. And it is interesting, of these 12 comets that did get brighter in about 10th magnitude, about a year ago at this time, we were doing the comets of 2023. And maybe about a third of the comets that actually became bright enough for reasonably sized backyard telescopes hadn't been discovered yet. So the brightest comet of the year, even for this comets of 2024, when I talk about the expected bright comets, it's very possible the best comet of 2024 is one that we don't know about yet.
Cool. That's always fun.
So as we're, approaching the end of 2023 here, there are a few comets that are observable at this time. There are 2 short period comets in the morning sky, 2P Encke. 2P Encke is kind of like the frequent flyer. It comes around every 3.3 years. In fact, it was first seen in 1786. And I think this is its 65th observed return.
Wow.
Which is amazing because there was a while back in the mid 1900s where we still didn't quite understand the structure of comets and how they behaved. But there were many predictions that Encke was going to disintegrate, that it was going to erode away to nothing. And there were predictions that it wouldn't survive till 1980 or 2000. But here it is going strong every 3.3 years coming back. And this is a comet that right now is about 9th magnitude and will increase up to probably about 5th or 6th magnitude before we lose it in the next week or 2 here. We also have Comet 103P Hartley. This was a comet that had a super good return back in 2010. It came within 0.12 astronomical units of the Earth, 1 astronomical unit being the distance between the Earth and the Sun, or 93 million miles. So it came really close, got up to 6th magnitude. The comet during that 2010 apparition was also visited by the Deep Impact spacecraft that was renamed Epoxy by that time, which was a NASA mission that originally had impacted Comet Tempel 1. And then after that mission, because the spacecraft was still in good working condition, because obviously the main spacecraft didn't impact Tempel 1. It was a little impactor that was sent, but the main spacecraft continued on and then flew by Comet Hartley. And so we have nice high resolution images of its kind of peanut shaped or bowling pin shaped nucleus. And right now, Hartley was supposed to get up to 7th magnitude, and it was kind of underperforming. And it was only getting up to maybe about 9.5 or 9th magnitude. Though right before the moon became a problem in the sky, all of a sudden it appeared about a magnitude brighter. So hopefully it will continue to get up to 7th magnitude, but right now it's looking like it might only peak at about 8th magnitude.
Okay.
Then we have one that I can't talk about too much because we're still kind of in the early stages of understanding it, but there's a Comet C 2023 H2 Lemon, which will pass 0.89 AU from the sun at the end of October 29th. It will also come really close to the Earth, 0.19 AU on November 10th of this year. And this is a comet that we call a dynamically old comet, in that it's probably been around before. And in fact, based on its orbit, we think it was last at perihelion 3,500 years ago. These comets have a habit of brightening very quickly, but it's possible that this could be a nice 7th magnitude comet in October-November timeframe. But right now, there's still some, it hasn't been well observed. It's coming out of the sun right now. Okay. But hopefully that'll be a nice 7th magnitude comet to kind of help close out 2023.
Cool.
And so now I can start talking about those comets that will be best in 2024.
All right, let's do it.
So the first one is one I did talk about in the comets of 2023, just because it kind of, its best period of observability kind of carries over from 2023 to 2024. This is a short period comet, and I'm going to go through these comets kind of in the sequential order of when they're observable. So this is Comet 62P Tsuchinshan, which I am probably butchering the pronunciation. Really, this is kind of the anglicized transliteration of what in Mandarin is Purple Mountain. So it's Purple Mountain Observatory.
Okay.
And so the Purple Mountain Observatory has discovered quite a few comets, and it's they discovered 61P and 62P. In fact, 61P and 62P were discovered only, I think it was like 10 days apart back in 1965. And it was kind of interesting that this comet 62P, when it was discovered in 1965, had just had a close approach with Jupiter. So it had just been kicked into a closer orbit around the sun. And it's basically kind of still in that orbit for the most part since then. And yet that 1965 return, it never got bright. It only got up to 15th magnitude or so. But then at a return in 1985, which was its next good return, it became 10th magnitude. So about 5 magnitudes brighter than what was reported in 1965, even though the returns were comparable. So either the comet, for whatever reason, just started acting brighter, or maybe it was bright back then, and being 1965, no one tried observing it visually to notice it really was that bright. Photographic observations were notorious for underestimating the brightness of comets. It was observed again in 2004, not as great a return, but still got up to 10th magnitude. And then the comet had two more close approaches with Jupiter, which kind of incrementally dropped its perihelion distance. And right now, the comet gets within about 1.38 AU of the sun. And as it turns out, this return right now here, really late 2023, early 2024, is probably the best return that we will have for Comet 62P over like the last 100 years and even going.
Oh my, very good.
So if it behaves like it has those previous two bright returns, it'll be a nice morning object and should break about magnitude 10 by mid-November and peak at around magnitude 9.0 at the end of December into early January. Okay. And it's well placed for both hemispheres. It's better placed for the northern hemisphere, but it's still, up pretty far for the southern hemisphere as well. So this is a nice comet that may be one of the only times, if you can only see down to 9th magnitude or whatever, this might be the only time you could ever see Comet 62P Schutzen-Shahn. Okay. Now, the interesting thing about that name is it will come up later, because there's another Schutzen-Shahn comet that we will talk about.
Good. You'll have the pronunciation perfect by then.
Yeah. Or I'll just have my wrong pronunciation nailed perfectly. So the next comet on the list is another short period comet. And this is 144P Koshida. This is a comet that comes around roughly every 7.5 years. It was discovered by Yoshio Koshida, who's discovered two comets, and they were both photographic, and they were both discovered about a month apart. And this was in December 1993 and January 1994. And the one in particular we're talking about here is 144P Koshida. And this was a comet that is, again, kind of interesting because its orbit hasn't really changed much. So how do we get a comet that gets discovered in 1994 and peaked at 9th magnitude in 1994 and yet wasn't seen prior to that? It definitely had a really good return in the late 50s, even better return in the late 50s than it had in 1994. So it should have been a 9th magnitude comet back then as well. Though if you do look at the orbit, the dynamical evolution of its orbit, it didn't have a lot of really good returns. So other than that late 1950 return, that was a late 56, early 57, it probably was too far from the Earth when it was at perihelion to be easily observable, at least, or discoverable by visual comet hunters, which were the norm at the time. But since that 1994 return, it seems that roughly every 15, 20 years, it has a really good return. And so I had another really good return in about 2009-ish timeframe. And now here we are in 2024. And the comet, again, if it behaves as it has in the past, should get up to about magnitude 8 or so, magnitude 8.0. And this will be in about February timeframe.
Okay, February.
And this is a nice evening comet. It always seems like most of our comets are in the morning, which means you have got to get up really early in the morning to see. This one is kind of nice in that it's an evening object. And it always seems to be at its best as it's kind of going through the Taurus region. So I remember when it was seen last time it was good, it was kind of going through the high 80s. And so there's a lot of nice photo ops as this goes through the sky there in the Taurus area.
Cool.
The next comet on our list is a long period comet. So the first two were short period comets. This is a long period comet. And this is C2021 S3 Pan-STARRS. Now, Pan-STARRS is one of the major asteroid surveys up there with Atlas and ZTF and Catalina. And Pan-STARRS has a pair of 1.8 meter telescopes on the island of Maui in Hawaii. And this was discovered with the Pan-STARRS 2 telescope back almost 2 years ago now, back in September of 2021. It also appears like it might be a dynamically old long period comet, though it has been brightening at a kind of slow rate. So it actually has been brightening at a rate that says it might be dynamically new, and that it might be making its first pass close to the sun. Those comets usually brighten slower, but the orbit suggests that it was dynamically old.
Okay. And
so we're not quite sure exactly how bright this comet will get. Recently, there have been observations of this comet that have been placing it around, say, 11th, 12th magnitude. And just assuming that it continues on kind of this slow brightening trend. And this is a comet that doesn't really get super close. It gets within 1.3 AU of the sun. Doesn't get all that close to the Earth. Again, 1.3 AU of the Earth, with perihelion in the middle of February and the closest approach to the Earth in the middle of March. But it should be brighter than about 10th magnitude starting in mid-December of this year through mid-May of next year.
Okay.
The peak at around magnitude 8.5, again at the end of February, beginning of March. This will be a morning object, and luckily it will be observable from both hemispheres. But this is one that could be around for quite a few months here in the first half of 2024.
Okay. But you think it's going to peak around 9th, you said, though, right?
Yeah, maybe 8.5 if we're lucky.
All right.
Yeah. Hopefully we've been proven wrong and it gets brighter. So the next two comets are Halley-type comets. Halley-type comets are, as the name suggests, they're kind of similar to Comet Halley in that they have longer periods for a periodic comet. They're usually defined as comets with periods between about 20 and 200 years.
Okay.
These next two comets have periods of about 71 years and 69 years, kind of similar to each other. And in fact, throughout history from their discovery, they've almost always shown up within a few years of each other. And just this year, it happens to be that they show up in the exact same year.
Okay.
So the first comet I want to talk about is 12P Pons-Brooks. Now, Pons and Brooks are the top two visual comet hunters of all time in history. A number that will probably never be surpassed, since I'm not going to say the era of visual comet discovery has completely closed, but that door is mostly closed.
Right.
There will be a few more discoveries, I'm sure of it, but it might be a number that you can count on one hand. Most comets are now discovered. Even most amateur discoveries are discovered using, digital means,
right,
with imaging. So Pons, Jean-Louis Pons in France, discovered 27 comets. In fact, he just got his 27th comet this year. He had discovered it back in the early 1800s, but it wasn't really entered into the annals as a Pons comet because no one else really saw it. And with a bit of sleuthing, it was determined that there were other observations of this comet, enough to make an orbit. And so Pons kind of retroactively got one of his comets back with his name on it, which was pretty cool.
That's cool. I like that.
Yep. And then William R. Brooks, who observed from upstate New York, discovered 21 comets. And this was mostly in the latter half of the 1800s.
Okay.
I mean, Pons was so good at finding comets that he actually discovered 2P Encke not once, but twice before it was recognized as being the same comet. And he also discovered comets that would later be recognized as periodic comets, like 5D Biela, the D because Biela broke into two and hasn't been seen since, 26P Griggs-Skejellerup, and 27P Crommelin, which is another comet that's named after, like Encke and Halley, named after the orbit computer rather than the discoverer. Okay. So he actually has even more than 27 discoveries. Those are just the 27 with his name on it. But he actually discovered other comets that weren't recognized as periodic comets at the time, but later on would be. And I don't know why his name wasn't added to them, but they weren't. And so these comets were recognized as periodic later. So Pons-Brooks was discovered in 1812, and it got up to about 4th magnitude. It was rediscovered by Brooks in 1884 when it got up to 3rd magnitude and had quite a significantly long tail during that apparition. And the last time we saw it was in 1954 when it got up into 6th magnitude. And that 1954 return actually saw the comet experience quite a few major outbursts, especially when it was on the inbound leg of, a few multi-magnitude outburst increases in brightness. There was work that was recently done by Mike Moyer, which found that this comet was seen in the past. It was seen in both 1385 and 1457. So like a lot of Halley-type comets that get reasonably bright, naked eye brightness like this comet had, it was seen in the past, though not at every return. And this return that's coming up, we'll see perihelion on April 20th at 0.78 AU. Unfortunately, this isn't a very good return, and that the comet never really gets close to the Earth. Wow. In fact, its closest to the Earth, and this will occur in early June, is only at 1.55 AU. Okay. So it's kind of a carbon copy of the 1954 return, the last return, when it got up to 6th magnitude. And that's kind of what we expect this time. So right now, the comet's already been observed. Okay. For a while, it was really underperforming the 1954 prediction. It was about 4 magnitudes too faint. And then in late July, boom, it had this giant 4 or 5 magnitude outburst. And in fact, the imagers observing the comet even now, and here we are talking about this in October, you can still see the resulting coma or dust release from that outburst there. And the comet's currently about 11th magnitude. So hopefully by December of 2023, it'll break magnitude 10. It will continue coming in, and it's mostly an evening object during this time. It'll continue brightening to magnitude 8 by January, magnitude 7 by February, magnitude 6 by the kind of the second half of February. And could get as bright as 5th magnitude by the end of March, when at least we here in the Northern Hemisphere and pre-perihelion, it's a Northern Hemisphere only object.
Okay, so there's potential for this one.
Yeah, when we finally lose it in the sun.
Okay.
After perihelion, we're talking very late April, early May, it'll become a Southern Hemisphere object, and it'll kind of just reverse the order as it fades from 5th to 6th, and eventually get down to 10th magnitude probably by the end of July or so. The other Halley-type comet coming back this year is 13P Olbers. This comet was first seen by Heinrich Olbers in 1815. It's one of only 3 comets that were named after him. And back at that 1815 return, it peaked at about 5th magnitude. It was recovered in 1887 by William R. Brooks, the same Brooks that discovered Pons Brooks. Mm-hmm. And in fact, if you go back and look at stuff from 1887, it is referred to not as Comet Olbers, but as Comet Olbers-Brooks. I don't know why Brooks's name was dropped off it, and why Brooks's name is on Pons Brooks, but not Olbers, but that's just the way it is. So right now, 13P is just Comet Olbers. And it was seen again in 1956 when it got up to about 6th or 7th magnitude. This year, perihelion occurs on June 30th of 2024 at 1.18 AU. Again, kind of like 12P, this is not a very good return. And in fact, this comet is even further from the Earth than 12P is, with closest approach to the Earth on July 20th at a distant 1.9 AU. It will probably only be a Northern Hemisphere object for the most part. And unfortunately, it will be a horizon hugger, but we do hope that it will peak at about magnitude 7.5 at the end of June or in early July.
Okay.
And barring a surprise discovery or a bright comet outburst or whatever, it's very possible that the brightest comet of 2024 is a long period comet that was discovered in January of 2023. And this is C2023 A3 Schutzen-Shahn Atlas. And yes, that is the same Schutzen-Shahn or Purple Mountain Observatory that discovered the first comet of 2024 that we talked about, which was the short period comet 62P.
Yeah.
Schutzen-Shahn Atlas is a long period comet. It's planned to be at perihelion in late September 27th of 2024 at 0.39 AU. So that's pretty close to the sun. And right after this comet was discovered, it was immediately talked about as being the next, great, brilliant comet. There are already news stories. It was kind of funny. I'm reading some news stories here that I cut and pasted, Newly discovered comet could outshine the brightest stars next year. Should be the best for several years, putting 2023's green comet in the shade. And that was, of course, the ZTF comet we talked about early 2020.
Right.
Or a newly discovered comet arriving in 2024 could be brighter than Venus. And both of these news headlines kind of have a smaller tagline that talks about how the comet hasn't been around. This is its first time in 80,000 years. So what happened was this comet was discovered. We knew how bright it was. We knew what its orbit was. Mm-hmm. And then and when I say we, I kind of mean the astronomical community in general, though not everyone agrees with these decisions, made a few key mistakes. One is that 80,000 years, it's been around in 80,000 years. They took an orbit that was pretty poorly defined, that didn't have a lot of observations, didn't have a long observational arc, and tried to determine whether the comet was, parabolic, hyperbolic, elliptical, and that would tell you whether or not the comet's been around before.
Right.
And the initial orbit said, oh, this one's been around before. That's good. Comet that's been around before probably will survive. And it probably will brighten at a pretty, normal rate, maybe even faster than normal rate. But as more observations came in over the following weeks and months, it became obvious that this comet has not been around before. It's what we call a dynamically new comet, and that this is its first time coming close to the sun. Now, why is that important? Why do we care about about dynamically old versus dynamically new. Well, the problem is many of history's greatest comet fails have been dynamically new comets. Think Ison, about 10 years ago. Didn't even survive perihelion. Think Austin, back in 1990. Did survive perihelion, but did not become the comet of the century. It became a nice backyard fourth magnitude object, but that was about it. Think Kohoutek, 1973, 1974. Again, a comet that was a really good comet, but again, was predicted to be comet of the century, negative 10th magnitude. And for the average person, the brightest they probably saw it was second or third magnitude.
Right.
And even if you go back to the 40s, Comet Cunningham, which was similar, that here was a comet that was predicted to be super bright because it was brightening really fast. And then as soon as that prediction was made, it kind of said, ha, and started brightening really slow and never got brighter about fifth magnitude. So will Tsuchinshan Atlas do the same? Possibly. And of course, the other problem was they predicted that it would brighten at a very rapid rate. So what you ended up with was predictions that this comet will get up to like negative fourth magnitude, which is the brightness of Venus at perihelion, or at least zeroth magnitude. And it's very possible it will brighten at a slower rate than that. The other problem is comets that are coming around for the first time, getting this close to the sun, like Ison, have a tendency of falling apart.
Right.
So it's very possible that this comet will fall apart before then. Now, it does have a few good things going for it. It does get close to the sun. Obviously, if you're going to have a nice comet, you want to get close to the sun. The comet gets hot, releases a lot of dust. Also, being close to the sun means it's seeing a brighter sun. So it's getting brighter as well as it reflects brighter sunlight. It will get pretty close to the Earth, actually 0.47 AU from the Earth on October 12th. That helps.
Mm-hmm.
On October 9th, it passes almost directly between the Earth and the sun. So it ends up having what we call an extremely large phase angle. Mm-hmm. The phase angle is the sun-comet-Earth angle. Why this is important is because at really high phase angles, dust in the coma will actually forward scatter. It will scatter. It will preferentially scatter the sunlight towards you in the forward direction. When you think most objects, when something shines on it, it scatters the light back at the source. When you have things the size of dust, it will actually forward at these angles. It will forward the sunlight. It will scatter the sunlight forwards towards you. And many of the best comets in history, whether it's McNaught's comet in 2007, Comet West in 1976, Aaron Rolland in 57, and even other comets going back like the Great Comet of 1861, or even Comet Halley at many of its returns. Mm-hmm. Fortunately, not the return we all saw in 1986. These comets are all enhanced in brightness by this forward scattering. And in the case of the McNaught comet, that was about 6 magnitudes of forward scattering. That comet looked 6 magnitudes brighter than it did because of dust forward scattering, which is why a lot of us were able to see it in the middle of the day, looking through small binoculars and stuff like that. So it's possible Tsuchinshan Atlas, when it does pass between the Earth and the sun, and again, this is on October 9th, my prediction has it being magnitude 2.5.
Oh.
But with the forward scattering, maybe it'll be magnitude -2.
Oh, my.
Now, is -2 really bright enough to see when you're only a few degrees from the sun?
True.
Remember, McNaught, we were able to do that, though McNaught was -6. And of course, there were people who saw Kiyosaki when it was really close to the sun, but it was probably more like -10. So I'm not sure -2 is bright enough. But as this comet comes in, it'll break about 10th magnitude, beginning of July, and it'll be an evening object at the time, though mostly a southern hemisphere object. We won't really see it from the northern hemisphere at the time. And even the southern hemisphere will probably lose it around sometime in August, when it'll only be up to about 7th to 8th magnitude. And so it'll mostly brighten when it's really close to the sun at really small solar elongations. We're talking like less than 15 degrees from the sun. So kind of like the Neowise comet, where we didn't quite know how bright it was as it was coming in because it was too close to the sun to be seen. Though luckily it was in one of the spacecraft field of views at the time. And then it kind of surprises us when it pops out, like, oh, look, it's first magnitude. It's possible Tsuchinshan Atlas will do something similar. There will be a point in late September when the comet will be observable at least a few degrees above the horizon in a dark sky from the southern hemisphere, and by then it should be third, fourth magnitude. But then it kind of drops back down again close to the sun. And then after it passes between the Earth and the sun, it darts out into the evening sky, mostly for northern hemisphere observers. Good. So if it has survived perihelion, and it is getting as bright as we're predicted, and with a little bit of forward scattering from dust, it's possible that, by October 12th, 13th, 14th, or whatever, we could have a nice first, second, third magnitude comet racing out. Around this time, we will also be passing through the comet's orbital plane, which means this comet should have a nice antitail as well. And the fact that antitail could end up being a little bit brighter than the main tail, just because the antitail being in the direction of the sun will be seen at higher phase angles. So the antitail itself will preferentially experience more dust scattering than the tail itself. So is it possible we will see kind of a replay of Comet Arend-Roland back from 1957? And if you don't know anything about Comet Arend-Roland, please just Google it, look it up, find old sky telescopes. It was pretty spectacular with that antitail. But there's huge question marks with this comet, just because it's probably dynamically new. We know those comets have a tendency of really letting us down. But there's some good things for it. And of course, it's going to be, when it's at its best, again, like most comets with small perihelion distances, it's just going to be too close to the sun. Mm-hmm. So we'll just have to wait and see on this. Yeah, but then again, Nishimura, there were all these great pictures of it super close to the sun. Though I tried looking for Nishimura on 5 nights, and 5 evenings, and I never was able to.
Yeah, I never saw it either. Yeah, you're usually pretty cautious with your predictions on comets, so I'm kind of excited about 2023. That's sounds like a nice one.
Yeah, hopefully it will be. It will be. Cool. Yeah, try to be cautious, because it's better to be surprised than it is to be disappointed.
That's true.
And especially nowadays with, everything's clickbait. Mm-hmm. You got to get people to click on your news stories. So everything is kind of overhyped, especially astronomy events. Things are just overhyped. Like, supermoon. It's like, it's just a full moon.
Yeah, well, when I publish this, I'll put a big headline that Carl Hergenrother predicts comet of the century in 2024. So I'll get lots of hits.
Hopefully it will be the comet of the year.
That would be nice.
That would be nice.
Yeah.
Whether that's 12P or this comet.
Yeah.
One thing I didn't mention about 12P, Pons Brooks, is that it could be a very good imaging comet, in that comet in the past has shown a lot of jet activity in the nucleus. Something we haven't seen in a while from a comet. Mm-hmm. And so this could be a nice comet for people who have got, reasonably good, resolution to watch jets form in the nuclear region. It's really been a long time since we've had a nice jet comet where you can see all these various features. I mean, nothing will approach probably what Hale-Bopp.
Right. That was a freak.
that was a more than once in a lifetime experience.
Yes, it was. Yeah. It was. Very cool. Well, you got anything else you want to share with us?
Just if you're interested in any way participating in the ALPO, or the Comets section in particular, we are open to all observations. Mm-hmm. And the easiest way to reach me is just to send an email to comets@alpo-astronomy.org. Also, every month, the ALPO Comets section writes up a kind of just a summary, a forecast of the comets that are observable for that month. You can find that on the ALPO Comets section page. And also, if you go to the Cloudy Nights Astronomy Forum, I also have the kind of more abridged version of that monthly, what I call the ALPO Comet News. Mm-hmm. I post that on the Comets Cloudy Nights Forum.
Very good. Well, Carl, once again, it's been a pleasure to have you on the podcast. And if any bright comets or other new discoveries happen, I'm sure we'll get together and do a podcast on them.
Oh, definitely. Yeah. And hopefully, Tucson and Shawn Atlas will prompt a more up-to-date podcast as we get closer or in the middle of what hopefully will be a nice apparition. Yeah. Or if not, maybe we can have a post-mortem as to, yeah,
it fell apart.
Yep.
All right. Well, it's been good chatting with you, Carl.
Thanks for having me, Tim.
All right. Well, that'll do it for this episode of the Observer's Notebook podcast. Again, I want to thank Carl Hergenrother coming on and talking to us about the comets of 2024. Let's get out and observe those. Sounds like we might have one or two really good ones. We upload a new episode of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please rate and review us. I would really appreciate it. You can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and the podcast is also available on the ALPO YouTube channel. You can help support the podcast by donating to it via Patreon by giving up to $35 a month, where you will receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I'd like to thank the producers of this podcast, Steve Siedentop and Michael Moyer, for their generous support. The link for Patreon is the link for the ALPO is in the show notes. You can contact me via email at cometman@cometman.net or on Twitter, ObserversNBpod. Until next time, I hope you always have clear and steady skies. Thanks for listening.